Hello and welcome once again to my channel. So today's lesson we're going to look at another example on how we simplify a block diagram and obtain the unknown parameters. So in this example we are told from the block diagram of a control system drawn below, determine the forward transfer function, the feedback transfer function, the control ratio, the error ratio, the open loop transfer function, and the primary feedback ratio. That is what you are required to obtain. Then the first thing you can see that a block diagram is not a canonical diagram because it has several blocks in the forward path. It has a block in the feedback path. So the first step is for us to simplify this block diagram to a canonical diagram so that we only have one block in the forward path and one block in the feedback path. So the first step, which rule do we apply first? So you can see that after at this summing point here, I have this block L1 in the forward path. Then at this point, I have the feedback path. I have this block B1, meaning that this is forming a closed loop. This is forming a closed loop. And when we are looking at the rules that we use to simplify a block diagram, we say that where we have a closed loop like this, we replace this one with an open loop system by obtaining the control ratio or the transfer function of this loop. So I'm calling this loop 1, and I'm going to get the transfer function or the control ratio of this loop 1. So that if I do that, I'll have C over R as my transfer function is equals to G over 1 plus or minus GH, like that. And this one is equals to G is the element that I'm having in the forward path. And in this case, I have L1 as my G. So I'll have L1 over 1 plus G is L1. Then H is what I have in the feedback path. So I'll have times B1. So the control ratio of this loop becomes L1 over 1 plus L1 B1. That's what we have. Then we say that after using a specific rule, then the next step is for us to draw up or redraw a block diagram representing that in one block. So if I plot another diagram, then I will have, this is my input, this is L2. Then after combining loop 1, I have the values here in one block. So I have L1 over 1 plus L1 B1. I have my output, then I have my feedback loop like this. Then from there, we look at the rule number 2, which we can apply. And in this case, of course, you can see that this block L2 is in series with this other block here. And then we're saying that for us to combine series blocks, we just multiply them. So if I just take L2 times L1 over 1 plus L1 B1, then I will have L2 L1 over 1 plus L1 B1. Because the two blocks are in series, we just multiply them, and after multiplying them, we redraw the diagram again. So if we redraw the diagram again, we have this is the block diagram. I have the summing point. I have my block here. Of course, I've combined the two series blocks, so I just have one block. I have the output. I have the feedback like that. So you can see I'm having only one block in the forward path, this loop, this block, and only one block in the feedback path, which is this block. So this is now forming my canonical diagram. So after having my canonical diagram, now I can obtain the parameters that I was required to obtain. Like the first question required me to obtain the forward transfer function. And the forward transfer function is our G. The feedback transfer function is our H. The control ratio is C over R. The error ratio is E over R. Then the open loop transfer function is is the GH, like that. Then the primary feedback ratio is B over R. So we're going to obtain all these parameters, and we'll start with the first one. The forward transfer function, we've said it is G, and G is what we have in the forward path, the block we have in the forward path. And in this case, our G is L1, L2 over 1 plus L1, B1. Then number two, we are required to obtain the feedback transfer function. The feedback transfer function. And then you see that this is our H. The feedback transfer function is what we have in the feedback path. And then this one is becoming B2. Of course, from the block diagram that we have, H is B2. Then we have the control ratio. Number 3 is the control ratio. We think that this control ratio is C over R. And this C over R is equals to G over 1 plus or minus GH. G is what we have in the forward path. So, of course, it is this value here. So, I have L1, L2 over 1 plus L1, B1. Then divide by, this is 1 plus G, still this value. So, L1, L2 over 1 plus L1, B1 times H. And in this case, our H is B2. So times B2, that's what we have. So the first thing is saying that we have to deal with this parameter first, because we know that this one, the same as 1 over 1, then plus this value over this value. So that the first thing, we just combine them to be under the same denominator. So that, so we will have the LCM is 1 plus L1 B1. So if I take 1 plus L1 B1 divide by 1 times 1, I'll have 1 plus L1 B1, then plus. If I take this value here, divide by this value, I'll just get 1. So 1 times L1, L2, B2, I have L1, B2, sorry, then L2. That's what we have. So I've just combined these two values to be under the same denominator like this. So then from there, I'll have now my C over R is equals to this value, which is L1, L2 over 1 plus L1, B1. We now change the division sign to be multiplication. So times the reciprocal of this value, which is 1 plus L1 B1 divided by this value, that is 1 plus L1 B1 plus L1 L2 B2, like that. Then from there you can see that these values are the same, so we'll just remain with 1. And then our control ratio C over R becomes L1 L2 times 1 is L1 L2 divided by, this is 1 times the whole of this value. We have 1 plus L1 B1 plus L1 L2 B2. That becomes our control ratio. Then from there we have number 4. Number 4 is error ratio. Then we have this is error ratio. This is E over R. Then we say that this error ratio E over R is given by 1 over 1 plus or minus GH. And in this case, we will have 1 over 1 plus G is L1, L2 over 1 plus L1, B1, and then times h, and h is b2. So that means if I multiply this, I'll have 1 over 1 plus L1, L2, B2 all over 1 plus L1, B1, like that. So of course, I'll need to combine these two terms by having the LCM, and the LCM is 1 plus L1 B1. So that if I take 1 plus L1 B1 divided by 1 times 1, I have 1 plus L1 B1 plus this one divided by this one is 1 times this is L1 L2 B2, like that. So I've just combined these two parameters by getting the LCM. That means after having that, now I have 1 divided by this value, which is the same as having the reciprocal of these values that I'm having here. So my E over R becomes 1 plus L1 B1 over 1 plus L1 B1 plus L1 L2 B2. Then number 5, we are going to obtain the open loop transfer function. And this open loop transfer function is our GH. So we have this GH is equals to L1, L2 over 1 plus L1, B1, then times B2. This is becoming L1, L2, B2 over 1 plus L1, B1. That is now our open loop transfer function. And then finally we have number 6, which is now the primary feedback ratio. The primary feedback ratio is B over R. So let us obtain B over R. We say that B over R is equals to GH over 1 plus or minus GH. So this one is equivalent to GH. GH is L1, L2, that's what we have here. Then B2 over 1 plus L1, B2, like that. Then divide by 1 plus G is L1, L2 over 1 plus or minus this is L1, B1. So this is B1. Then times G, which is H, which is B2. So that means we need to combine these two by getting their LCM. So I can have over 1. So that if I work out this one, the LCM is 1 plus L1 B1. Then divide by 1 times 1 is 1 plus L1 B1. Then plus this divided by this one is 1 times this is L1 L2 B2. That means now I'm going to have this value, which is L1 L2 B2 over 1 plus L1 B1. I change this division sign to be multiplication. So times the reciprocal of this, which is 1 plus L1 B1 over 1 plus L1 B1 plus L1 L2 B2. Of course, this and this will cancel out, and then we remain with our B over R as L1 L2 B2 over 1 plus L1 B1 plus L1 L2 then B2. That becomes our answer. And that's how we simplify block diagrams and obtain the unknown parameters. Thank you so much for watching. And please, if you're new to my channel, consider subscribing, liking, and also sharing to your friends. Thank you so much.